Hey everyone! Welcome back to The Next Generation. In this video, we're diving into a super important concept in data structures, the linked list. Whether you're preparing for interviews or just starting DSA, this is something you absolutely need to understand. Let's start with a simple question. Why do we even need a linked list when we already have arrays? Well, arrays have a fixed size, so if you want to insert or delete elements in the middle, it's not very efficient. Everything shifts. This is where linked lists come in. They provide flexibility with memory and allow faster insertions and deletions. A linked list is a linear data structure where elements are not stored in contiguous memory. Instead, each element is called a node, and each node has two parts, the data and the pointer to the next node. In simple words, a linked list is like a chain of boxes, where each box holds some data and a reference to the next box.
Let's visualize it. Here, 10, 20, and 30 are the data. Next is a pointer to the next node. And the last node points to null, meaning the end of the list. There are three main types of linked lists. Singly linked list, each node points to the next one. Doubly linked list, nodes point to both next and previous nodes. Circular linked list, the last node connects back to the first node, forming a loop. Imagine a treasure hunt. Each clue leads to the next location. You can't jump to the end. You have to follow each step. That's exactly how a linked list works. You traverse it node by node. Some common operations you can do on the linked list are traversal, visiting each node, insertion, adding a node, deletion, removing a node, searching, looking for a value. Now let's code these one by one.
This is the node class. Each node in our linked list contains two parts, an integer data to store the value and a pointer next to link to the next node. In the constructor, we initialize the node's value and set next to null PTR since it's not connected to anything yet. This is our lit class, which manages the whole list. We define a head pointer that points to the first node. In the constructor, we initialize the list to be empty, so head is set to null PTR. Then a function called insert at beginning is used. This function inserts a new node at the beginning of the list. We first create a new node, then we point its next to the current head. Finally, we update the head to be this new node.
This function inserts a node at any position in the list. If the position is 0, we treat it like inserting at the beginning. Otherwise, we loop through the list until we reach the desired position. If the position is invalid, we show an error. This function searches for a given value in the list. We traverse each node and check if the data matches the key. If found, we return true. If we reach the end without finding it, we return false. This function prints the entire linked list from head to tail, ending with null 2p to show the end of the list. Now it's your turn. Try to write the code to insert a new node at the end of the linked list. Use the concept we just learned. Create a new node and connect it after the last one. If you get stuck, don't worry. I've added the full code link in the description so you can check and compare your solution anytime. Give it a shot first and then come back to continue. In the main function, we insert 10 at the beginning. It becomes the head. Then insert 20 at the beginning. Now the list becomes 20, and then 10, new head is 20. Then insert 30 at the end. The list becomes 20, 10, and 30. Finally, we insert 25 at position 2 quote, so the list becomes 20, 10, 25, 30. Then we search for two values. First, we look for 20. It's present, so we print that it was found. Then we search for 22, which doesn't exist in the list, so it prints not found. Now let's look at how to delete a node from the beginning of a linked list in C++. We start by checking if the list is empty. If the head is null, there's nothing to delete, so we just print a message and return. Next, we store the current head in a temporary pointer called temp. This is the node we're going to delete. Then we move the head pointer to the next node, effectively removing the first node from the chain. Finally, we delete the old head node from memory to avoid memory leaks. Now let's look at how to delete a node from a specific position. We begin by checking if the list is empty. If the head is null, there's nothing to delete, so we just print a message and return. If the position is 0, that means we want to delete the first node, so we simply call the delete from beginning function to handle it. Now we create a temporary pointer and move it to the node just before the one we want to delete. We loop until we reach position -1, unless we hit the end of the list early. If we reach a point where there's no node at the desired position, we print a message, position out of bounds, and exit the function.
Otherwise, we've successfully reached the correct position. We store the node we want to delete in node deletes. Then we update the previous node's next pointer to skip over the node being deleted. And finally, we safely delete the node from memory. That's how you delete a node from any given position in a linked list.
Now try writing the delete from end function on your own. Think about how you would reach the second last node and disconnect the last one. And if you get stuck, you can always check out the full code link in the description or just ask in the comment section. Now, in our main function, the original list from previous codes was 20, 10, 25, 30. We call delete from beginning. This removes the very first node of the list, which is 20. After deletion, list becomes 10, 25, 30. Next, we call delete from end to remove the last node of the list. So the list goes from 10, 25, 30 to 10 and 25. And now we delete the node at position 1. That means the second node in the list. So now the list is 10.
And that's all for singly linked lists. In the next video, we'll dive into doubly and circular linked lists and explore how they work. If you found this video helpful, do not forget to give it a like, share it with your friends, subscribe to our channel, and drop a comment if you have any questions. We're always here to help. Follow us on Instagram using the link in the description below. For the full code, check out the link in the description as well. Thank you so much for watching. Keep learning and stay with us on The Next Generation.